everyone, in this video let's discuss how to solve the rank of matrix problem using the normal form. So you can solve the rank of matrix using normal form and the echelon form. Echelon form is much easier because you will only apply the row transformation in the echelon form. But here in the normal transformation you will apply both row transformation and the column transformation. So the problem length will be much more, but it is easy to solve the problem. Now, the given matrix must be converted to the normal form. So, here I am having the 3 cross 3 matrix. If I consider 3 cross 3 matrix only, in the normal form, it must be like this. That is, the diagonal elements value must be equal to 1 and all the elements below the diagonal element must be equal to 0 and the element below the above must be equal to 0. So, the diagonal elements must be equal to 1 and the elements below it and above it both must be equal to 0. So, this will be the normal form. Now, let's convert the given matrix into the normal form and check the rank of the given matrix. So, now the first element is 1. I needed to convert the diagonal element as 1. But here it is already 1, so no need to convert it. So, just write as it is. Let me name the matrix as A, and my goal is to convert the element below the diagonal element as 0 and the elements which are rightward towards it. That is, I must convert all the elements which are below it as 0 and which are to the right side as 0. That is, its corresponding row and the corresponding column elements must be equal to 0, like that. So, if you see here, this is row number 1, this is row number 2, this is row number 3. Row number 1, 2, 3. First, let's apply the row transformation. Later, let's apply the column transformation. So, here if you see, the diagonal element is 1. I need to convert 4 and 7 as 0. That is, I must apply the row transformation for R2 with reference of R1 and R3 with reference of R1. Because R1 is the row which is having the diagonal element and its value is 1. Now I must convert these two as 0, no? So I must take the reference of that row. Now to convert 4 as 0, I will be writing the opposite. That is, here I am having plus 4, here I will write minus 4. Here I am having 7, I will write minus 7. So this is the simple trick, write the opposite. Now I am applying the operation for row number 2 and row number 3. So, row number 1 value will remain as it is from the previous step. I applied these two operations to make 4 and 7 as 0. So, I will write them directly as 0. Now, just find the 4 values. First, let's apply the row 2 operation. So, what is the row 2 operation? R2 minus 4R1. Take 1 by 1. Here I am having 5 as the row 2 value and its corresponding row 1 value is 2. So 5 minus 4 into 2. 5 minus 4 2 is 8. 5 minus 8 will be minus 3. Next, row 2 value is 6 minus 4 into row 1 value is 3. So 6 minus 4 3 is 12. 6 minus 12 will be minus 6. Now let's apply the row 3 operation, that is R3 minus 7R1. Here the row 3 value is 8 and row 1 value is 2. So 8 minus 7 into 2. 8 minus 7 2 is 14. 8 minus 14 means it will be minus 6. Next, 9 is the R3 value minus 7 into R1 value is 3. So 9 minus 7 3 is 21. 9 minus 21 will be minus 12. Now, if you see here, 1 is my diagonal element, that is the first diagonal element, and the elements below it are equal to 0. Now, my job is to convert this 2 and 3 as 0. So, to convert these two as 0, I will be applying the column transformation. So, this is column number 1, column number 2, column number 3, like that. Here I don't need to change the value of column number 1, I just need to change the column number 2 value and column number 3 value with the reference of column number 1. So the simple trick to convert them as 0 is just write the opposite. Minus 2 here, minus 3. Now write the updated matrix. Here I am applying the operation only to the C2 and C3, that is column number 2 and 3. So the column number 1 value will remain as it is. I am applying these two operations to make 2 and 3 as 0. So just write 0 directly. Now just find the 4 values. First let's take the column number 2 operation, that is C2 minus 2 into C1. So the first C2 value is 2. Now I must fill the value here now. So C2 value is minus 3, minus 2 into C1 value is 0. So minus 3 minus 2 into 0 will be 0 itself, just write minus 3. Now another one is C2 value is minus 6, minus 2 into its corresponding C1 value is 0. So 2 into 0 will be 0 itself, minus 6 is left. Now let's apply for the row 3. Now let's apply for the column number 3. So column number 3 formula is here C3. So C3 is minus 6 minus 3 into its corresponding C1 value, that is 0. So minus 6 minus 3 into 0 will be 0 itself. So no need to write it, just write minus 6. Now another one is minus 12 minus 3 into corresponding column 1 value is 0. So 3 into 0 will be 0 as itself and only minus 12 is left. Now if you see here, so the first diagonal element is 1 and the value below it and rightward to it are equal to 0. Now let's move to the next diagonal element. Here I am having minus 3. I must convert it to 1. So first we will apply the row transformation. So what I will be doing, this minus 3 is in row number 2. Row number 1. Row number 2. So row 2 divided by minus 3. Whatever the value will be here, just divide by itself. So you will be getting the value as 1. Now I only applied the operation for the row number 2. So row number 1 and row number 3 value will be equal. That is the same from the previous step. 1, 0, 0, 0, minus 6 and minus 12. Now 0 divided by minus 3 will be 0 itself. Minus 3 divided by minus 3 will be 1. Minus 6 divided by minus 3. Minus minus cancel. 3 ones are 3 twos are. So 2 will remain here. Now my second diagonal element is also equal to 1. I must convert the value below it and rightward to it as 0. Now let's convert the minus 6 as 0. So minus 6 is in the third row. Row 1, row 2 and row 3. So what I will be doing? Row 3 with the reference of row 2, because the one which is the diagonal element which is responsible for converting minus 6 into 0 is in the row number 2. Row number 1, row number 2. So I must take the reference of the row number 2. How to convert minus 6 as 0? Just write the opposite, that is plus 6. So here I am applying the operation only to the row number 3. So row number 1 and row number 2 value will remain as it is from the previous step. 1, 0, 0. 0, 1 and 2. Now 0 plus 6 into row 2. So 0's corresponding R2 value is 0. So 6 into 0 will be 0. 0 plus 0 is 0. Next one. R3 value is minus 6 plus 6 into R2 value. So R2 value is 1. Plus 6 and minus 6 cancel. So value will be equal to 0. Next. Here R3 value is minus 12 plus 6 into R2 value is 2. So minus 12 plus 6 2s are 12. 12 and 12 cancel. Minus 12 and plus 12 cancel. You will get the value as 0. Now, you have converted the value below the diagonal element as 0. Now you must convert 2 as 0. So how to convert 2 as 0? Now apply the column transformation. Once you apply the row transformation, now apply the column transformation. So this is column 1, column 2, column 3. So this is in the column number 3. You must take the reference of the column number 2 where the diagonal element is 1 and which is responsible for converting 2 as 0. So how to convert 2 as 0? Just write its opposite, that is minus 2. Now the updated matrix will be, you are only applying the operation for the column number 3. So column number 1 and column number 2 will remain as it is from the previous step. 1, 0, 0, 0, 1, 0. Now 0 is the C3. First C3 minus 2 into its corresponding C2 value is 0. So 2 into 0 will be 0, 0 minus 0 will be 0. Next C3 value is 2 minus 2 into its corresponding C2. Next C3 value is 2 minus 2 into its corresponding C2 value is also 1. So 2 into, so 2 minus 2 will be 0 itself. So write 0. Now the last one is C3 value is 0 minus 2 into its corresponding C2 value is also 0. So 0 minus 0 will be 0 itself. Now if you see here, the diagonal elements are equal to 1, but here I am having 0. So this is the special condition where when you subtracted the element you got the final answer as 0. So now you can't convert it to 1. So this is the special condition which is allowed in the matrix also, that is in the normal form. So the diagonal elements can be 1 or it can be equal to 0 in some condition. It is also allowed. So it can be equal to 1 or 0, not other values are allowed. And the elements below it must be equal to 0 and the element above the diagonals must be equal to 0. Now you have converted the given matrix into the normal form. Now how to find the rank of the matrix? So the rank of the matrix will be equal to the number of ones in the diagonal of the normal form. So here if you check the diagonal 1, 1, 0 are the value. So how many times 1 has repeated? So how many times 1 has repeated? 1, 2. 2 times 1 has repeated. So the rank of the given matrix is 2. How many number of times 1 will repeat in the diagonal elements? That will be equal to the rank of that matrix. So hope you understood how to find the rank of the matrix using the normal form. And the echelon form video is given in the description. You can access it. And if you liked the video, please subscribe and support us. And if you have any doubt regarding this topic, please do comment below. I will clarify it. Thank you.